To check the symmetry with respect to x-axis, all we have to do is replace y in the equation by negative y, replace y by negative y, and see if we get the original equation back. For y-axis, we replace x by negative x and see if we have the original equation back. For the origin, to check for symmetry, we replace xy by negative x, negative y, and then see if we have the original equation back. Okay, xy by negative x, negative y. So for the first equation, y equals x cubed minus x, let's check for x-axis symmetry. So x-axis symmetry, we replace y by negative y. So we have negative y equals x cubed minus x. Now we want to see if this is the original equation. Okay, so in the original equation we have y, so now we got negative y. So to get rid of this negative, we multiply both sides by, let's say, negative 1. Or we could have divided by negative 1 as well. Negative 1 times negative y is y. That's what we want in the back, in the front, in the left. Negative 1 x cubed, negative x cubed, negative 1 times negative x plus x, basically distributing negative 1. And this is not the original equation. Okay, the original equation has x cubed minus x, we got negative x cubed plus x. So no x-axis symmetry. Okay, so the x-axis symmetry, no. But we need to check more, so we need to check for y-axis symmetry. For that, we replace x by negative x. So we get y equals x cubed means negative x quantity cube minus x is negative x. Negative cube, negative, negative, negative 3 times negative x cubed, negative, negative, positive x. And this is not the original equation. So no y-axis symmetry. Now we check for origin symmetry. Origin symmetry, for we replace x by negative x and y by negative y. So original equation is here, y by negative y, x by negative x. So negative x cubed minus x is negative x. Let's simplify. This is negative y equals negative cube negative 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 x cubed negative negative positive x. To check if this is the original equation, so we have y in the left side, negative y. Let's multiply by negative 1 to get rid of this negative. We could have divided by negative 1 as well. Negative 1 times negative y, just y. Negative 1, negative positive x cubed, negative positive negative 1xx. And this is the original equation. Okay, y equals x cubed minus x. So yes, this graph, this equation has origin symmetry. Okay, this is yes. So the equation has origin symmetry, and later we will call origin symmetry as odd functions. Okay, let's try for B. Same procedure. To check for x-axis symmetry, we replace y by negative y. Then this becomes 4x squared minus y squared. Y means negative y squared equals 5. This is 4x squared minus negative squared. Negative times negative, positive, and we have negative, just negative y squared. Okay, this negative square is positive, that we don't have to write, equals 5. Okay, we simplified. Is this the original equation? 4x squared minus y squared equals 5. Yes. That means this graph has this equation. This equation has x-axis symmetry. Okay. Yes, the equation has x-axis symmetry. Let's check for y-axis symmetry. For we replace x by negative x. So in the original equation, so 4x squared, 4 negative x squared minus y squared equals 5. 4 negative squared, that's positive. Okay, negative positive, x squared minus y squared equals 5. And this is the original equation. So yes, this is the original. So the equation, the given equation has y-axis symmetry. And finally we have to check for origin symmetry. For we replace x by negative x and y by negative y. But if an equation has x-axis and y-axis symmetry, both symmetries, then it will be automatically it will have origin symmetry. Okay, yes, you can check, or because the equation has x-axis symmetry and y-axis symmetry, it also has origin symmetry.